Welcome class. Today we're going to learn about how to tell whether a point is on or off a line when you graph it. But sometimes you just need to know with calculations, so that is where we're going to go today. So first thing we're going to do is we're going to do a quick review over what we discussed last week, which was how to make a graph of a line using only coordinates or ordered pairs. So in order to do so, what we did first was we made a 3-column table. The first column was your x. The second column was your equation, 3x minus 4. And the third column was your y value. Then what we did was we picked 3 values. They could be either positive or negative. Maybe I'll just pick positive numbers this time, 0, 1, and 2. Then what we did was we substituted each value in for x and found the answer by using the order of operations. So 3 times 0 is 0, minus 4 is negative 4. Repeat the process with 1. 3 times 1 is 3, minus 4 is negative 1. And then 3 times 2 is 6, minus 4 is 2. After we had those, the value in the first column and the value in the last column gives you your ordered pair. So the first ordered pair we plot is 0, negative 4. So I start at the center and I go 0, negative 4, and I plot a point. I then go to 1, negative 1, and I plot another point. And my third point is 2, 2. So we go right to, up to, I plot my third point. Using a ruler or a straight edge, we then draw ourselves in a line that goes through all points, that extends forever. It must be straight because it is a straight arrangement of points, and we put arrows on the ends because it goes on forever. And there's our line. Now remember, if you plot your points and they don't make a line, your calculation is off somewhere. So that's a little bit of review of what we did last class period. So today we're going to talk about how to go about finding if a point actually is on the line or off the line. So the steps that are needed are 1, substitute the x value into the equation. 2, evaluate using order of operations or OOPS. 3, check the y value. If the solution is equal to the y value in the ordered pair x comma y, then the point is on the line. Otherwise, the point is off the line. So we're going to use these 3 steps to help us. If you want to take a minute and write these steps down, you might want to freeze the video and come back to it or pause. Okay, so now we have our 3 steps. We're going to go ahead and try just a couple examples. Example 1 says y equals negative x plus 9. It is an equation of a line, and I have 3 different ordered pairs here, and I want to know which points are on this line and which ones don't match or are not on the line at all. They're off the line. So first I got to realize what y equals negative x plus 9 means. Now you can look at it one of 2 ways. It could say y equals the opposite of x, or you could actually think of it as y equals negative 1 times x plus 9. We'll treat it that way. So now what I do is I take my equation that I had, y equals negative 1 times x plus 9, and I'm going to put in my x value. So my x value is 8, so we're going to do negative 1 times 8, and then it says plus 9, just like we were substituting in before using the table. Well, let's see. Y equals negative 1 plus 8 is negative 8 plus 9. So y equals negative 8 plus 9 is positive 1. Now all I have to do is check my answer by coming up to my original problem and looking at my ordered pair. My ordered pair is 8 and negative 1. It said I should put in an 8 and get a negative 1 as an answer, but I didn't. I got a positive 1. So no, this point does not lie on the line, which means if I were to graph this line using a table, this point would be somewhere other than where the line exists. Let's try another one. 0, 9. So we start by writing our equation. So y equals, we go back to the original problem, so -1 times the x value, do they tell me? 0 plus 9. Now I use my order of operations. I multiply first. -1 times 0 is 0 plus 9. And then 0 plus 9 is 9. Now I'm going to check it. So I come back up and look at what my y value should have been, 9. Well, I got 9. So yes, this is the actual point on the line. Let's try one more with this equation, and we'll try one other equation. So the last equation, y equals -1 times my x, which is -3. And remember, parentheses are the same thing as just multiplication. If you want to use a dot instead, that's fine. Plus 9. So we get y equals -1 times a -3, which is a +3, plus 9. And 3 plus 9 is 12. I check my answer, I come back up, I look at my problem, they say the answer is 12. I got 12, so yes, this point does exist on the line. So it's a pretty easy process. Substitute your x in, evaluate it, and then check to see whether or not your answer worked. We're going to do one more problem, and please hang in there with me because we really need to do another one. We're going to talk about with a fraction. So the fraction I picked was y equals 3/2 x minus 4. The reason why I picked fractions is we tend to struggle with those. So the first problem we're going to do is we're going to see if 2 and -1 actually exists on the line. So we write our equation. So y equals, says 3/2 x. Remember that means times. X, well our x is a 2. And then it says minus 4. Now remember, if you don't have a denominator, the denominator is 1. If you know how to cross simplify, you can cross simplify. If you don't, we just multiply across. 3 times 2 is 6. 2 times 1 is 2. 6 divided by 2 is 3. So it's 3 minus 4, which is -1. Now I need to check my answer. Come up here and look at my problem, and it says y should be -1 because it's x comma y. So we're good. Yes, this point lies on the line. Let's try another one. So y equals, this time we're going to try 4, 1, so 3/2 times 4 minus 4. So I put it over 1. 3 times 4 is 12. 2 times 1 is 2. Minus 4. 12 divided by 2 is 6. Minus 4. So we get y equals 2. Check my answer, bring it up here, look at it. My answer should have been 1, but I got a 2. So no, this is not the right ordered pair for that line. One more time, let's throw in a negative this time. So last problem, y equals 3/2 times my x value, -6 over 1. And then it says minus 4 in the problem. We don't know how to cross simplify, we multiply across, so we get -18 over 2. Minus 4, same signs positive, different signs negative. So -18 over 2 is -9. Minus 4, well -9 minus 4 is -13. So let me check to see if I got the right answer. Come up here and it says I should have gotten a +13. Well, this point would have worked if it was a -13 in the end. So the answer is, once again, no. Hopefully this is helpful. When you get done with this video and have recorded your notes, I need to check them, and then you have an activity sheet that corresponds along with this. Thanks.